Bioada has 3 products: Smart Array, Xarang, and Happy Reader. In this video, we are going to talk about Xarang, a powerful real-time machine learning toolbox, which is very suitable for analyzing genomics data. We open Xarang. The first tab, we have 4 buttons. The first one, new, for creating a new project. The second one, opening the existing project. Third, saving project as with a new name, or we can also merge projects. And this is a very unique feature of Xarang. The second tab is the data. First, we need to create a new project. We use we call this project just PRS, polygenic rhesus score. And then the second tab is the data. We can get the data from local machine. We can get multiple data from a folder. We can get the data from a database, any type of database, also from the cloud. Then the data we are going to use is a pancreatic cancer. We use the trained data set. The next tab is about learner. In this step, we extract all the required statistics, aggregates here. We choose our target, which is the target factor, which is a value between 0 and 1. 1 means pancreatic cancer, 0 means healthy. Click here. This is the variable name, and this is the data type. We ignore this one. Also target. We can keep gender, but remove two more states. We can keep age, but remove operability, and there's 2 random variable. Click. In 1 second, we extract all the required data. We move to the Explorer. Explorer for univariate bivariate analysis. For example, you can click here and you can see all the univariate statistics: count, sum, mean, variance, CV, skewness, and correlation. You select any variable on the right, you see the correlation between that variable and the other variable. You can select any number. You see it's very quick because we are using the aggregate. Now you click on the plot, you can see the relationship between the selected variable and other variable. Hypothesis testing is about the z-test, t-test, f-test. You select one continuous or numerical variable and one binary and click on z-test. You see that these 2 average the count between target factor. It means here 1, complement means 0, and then this is the average of these 2, and the variance z value is very high, probability 0. It means the difference between 2 averages are statistically significant. And then we can do the t-test if the number of our data points are less than 30. F-test to compare the difference between 2 variances. Okay, for example, here we see these 2 variances are the difference between 2 is not significant, statistically significant. We can also plot and see the range of two group. And analysis of variance is the same thing, but if you have, usually we use it if you have more binary variable. It means our target has more than 2 value, and then we click and we get the analysis of variance table. F value is high, probability is very low. Again, analysis of variance confirms which this is the average between 2 groups are statistically the difference are statistically significant. We can again plot, and also we can see the statistics about the mean variance here. Test of independence is when we want to compare binary variables together, and here we just have one the same. Then you see there's going to be two values. Target factor is 1, complement is 0. But if you have more than 2 value for a target, a categorical target, you're going to have more item in this tool list. Okay, factor analysis is just the same as principal component, and we use the principal component to do the factor analysis. You can select any number of the variable, click on factor analysis, and you can see all the information about the factor. You can click here to sort them, and then you can also see the scree plot. For example, here we clearly see the 5 factors are enough to explain the variability of our selected variable. And then next step is going to the modeler. We have classification and regression capability here. This is this classification method is based. The algorithm behind this classification is linear discriminant analysis. The first thing we select our target, and we can select any number of the variable here and simply click on model, and we can see this is the LDA model. Overall contribution, which shows the Mahalanobis distance value here. It's the probability of the first class, second, and then I can easily change, but the best to change the other variable to find the best combination, or just use this button to do the same thing, variable selection automatically. But here we need to define the minimum amount of the Mahalanobis distance for accepting a variable. It means if I add a new variable and I get extra 0.1 for to overall Mahalanobis distance value, then I accept it. And I put this one as a minimum, which means I accept a new variable only if I see 0.1 standard deviation added to Mahalanobis distance. Then I select everything and click on reducer. As you can see, we are building model automatically here, and after building 420 models in less than 10 seconds, it found 24 variables with which give us a lot of power. 9.7 standard deviation is high. Then we go to 2. I like to start with a smaller set of the variable. Then I select everything, run it again. This is good. It's again 412 models built in 3 seconds. Again, we have a very good number with 12 variables. And I save this one as my cell vars. I can go even higher, but at this stage for this demo is enough. Then I select my test set and select my 12 variables, and as you can see, this is a perfect model, which is not surprising because we had the very good model here. Then we can see all the evaluation statistics, sensitivity, specificity, positive predictive value, negative predictive value, and the other number. This is the accuracy, which is 100%. This is the total number of the data in the test set. This is a model we use, which is LDA. This is our target. And another useful feature here is this is a decile chart. For example, if I just select 2, it means all the my target is on the second. It's on the second part of the score. It means if I sort the score from lower to higher, every target I have is on the upper section, and that shows. But because we have the 100% accuracy, really this one doesn't matter. Then the next one is we can open a new window to do, if we want to do more analysis, we get the scores. This is our target, which is target factor, and this is the scores. This is a gain chart, which is on the 10%. We have more than 3 times better result from the model. Left, which is the same, but just we see the number 3 times. ROC should be perfect, 1. This is the most important chart. KS chart shows the huge difference, an excellent separation between 2 classes, 1 and 0. And for confusion metrics, you need to use the predicted value. Same thing, 100% accuracy, and all those numbers are great. Okay, if we like this model, Xarang has another unique feature, which is a quick deployment, which means we can look at the script and we save the data. We call it, say, same thing, PRS, which is for now. And if we go to the folder, we see it's the export folder, and this is our file. We can go to the deployment, connect, and we have a PRS before. Then I can delete this one and then get my new file called PRS and upload it to the server. And I believe we should be able to see it now. This is the server, and yes, this is our PRS. Now you have your model is ready. It means this is just the demo server, but you can have the same thing. It means in a few clicks you can deploy your model and use it and predict. Okay, thank you so much.